With this session, we'll try to break the barrier of complexity level that Java has, and we'll break down the complexity that Java has, and we'll help you decide an approach to get started with the Java in an efficient manner and in a fruitful manner. So today's agenda is we'll discuss, some sort of approach or few approaches to start with the Java programming language. Then, we'll see into some of the guiding steps. We'll see how to utilize, how to find resources, and how to practice Java language efficiently. I'll share one learning methodology with you guys, and which would help you drill down and understand necessary steps to be taken to start with Java. Then we'll discuss some protocols, some set of rules which would help you in understanding the mechanics of Java. Then we'll discuss, importance of evaluation and how to keep ourselves evaluated and how to progressively evaluate ourselves for the betterment. Then we can take the questions or whatever questions we will have by that time in the chat. We can take those questions and we can answer it. So if you have any questions in between the presentation, you can send across those questions into the chat box, and Gitesh is moderating those questions as a Techcanvass admin. So you can send over those questions. We can take those questions at the end of slides. So starting with approach. Anything, if we start with a major leap, has a more probability of failing than otherwise. So basically in Java, we should have a minimalistic approach. Okay. So we should start with a minimalistic approach, and we should follow a particular guideline to learn a particular language, right? By a minimalistic approach, what I mean is that we do not want to take a very big leap in understanding all the underlying Java libraries, all the underlying Java concepts. Okay, we can start with basic, and we can follow the best practices that Java developers have done. So Java is, a very large community of developers, and there are a lot of contributors. So Oracle, is investing a lot in Java, keeping it as, one of the top rated programming language. So Java is really vast. So we cannot, straight away start with programming lambdas or using collection classes, right? So initially, the approach that we should follow should be minimalistic, should be basic. We should start with, writing small programs, developing small calculators, writing code for say simple interest or compound interest calculators, or writing code for computing modulars, percentages, factorials, right? So this is what we mean when we say that we should have a minimalistic approach, and we should keep on building that approach to proceed further with our language. So in line with this minimalistic approach is the bottom-up approach. So in training industry or in programming learning industry, if you see the a paradigm of learning any programming language, we should start with the basics. So bottom-up approach is, we should start with bits and pieces, and then we should integrate them in order to make our knowledge paradigm really strong. So bottom-up approach is, we should start with the minimalistic approach. and we should start with the pieces. For example, when someone in a professional world, I'm not talking about students, but someone in professional world, when they start learning anything new, they start right away with the actual work that they have to do. So this is a little unfair with the language, because you have to understand the basics first. You have to write small programs which do not make much sense initially, but they are necessary to build up the concept. I'll give you an example. For example, if you consider Java, so in Java, generally we write programs. As a beginner, we write programs of calculating, compound interest, or we calculate factorial, or we calculate Fibonacci series, right? Or we print the stars. We write program to print a star, okay, on the console window. So these programs, uh, these programs are not meant to be learned or understood. These programs are used to make the concepts. Okay, so when we say that we should use the bottom up approach, we mean that we should start with the basic programs, and then we should go ahead and keep on improving our knowledge. For example, if we do not understand how a for loop or any loop would work, we cannot effectively use any collection class, right? If we directly start working on something, we'll definitely end up messing our collection and memory management, and our logic paradigm or a logic building block for any program that should be there would not be there. So in order to handle such scenarios, we should always start from bits and pieces, and then integrate those bits and pieces to build a more complex or concrete knowledge paradigm. Okay. So, you know, uh, it's easier said than done that, we need to start, but we need some steps, some concrete things that we need to start with undertaking. And so those things which we need to uh, do while learning or while stepping into Java, I have, decomposed them into several steps. And these steps are, very necessary uh, to do. Each step has its own importance, and we should do it in order to become an effective Java programmer. So initially, if you look at the Java language, if you go to any tutorial, if you look at the curriculum, or if you pick up any book, you might get scared, right? Because there is a lot of it, right? But following the structured steps to undertake can make the things a little easy. So first quadrant is remember. So we cannot remember everything. Our memory has a limitation. Okay, so it is important to distinguish what to remember and uh, what is okay if we do not remember. Okay, so it is important to distinguish this thing first. So as you undergo any training course, or as you undergo any knowledge sharing session, you get to know, or if you follow any tutorial, you get to know that what is important to remember. Okay, second thing is understand. So generally, if we are asked to create anything from scratch, or I mean, based on your experience, you must recognize this, or you must correlate to this. Or if we are given a task which is inflied by some other developer or a tester, what we tend to do, we just try to finish the task without understanding all the aspects of it completely. uh, Specifically in Java, if we do this, we might fall into pitfalls. Okay, because Java, if you understand, it will be really easy. The complex concepts, or the advanced Java, which we call it, is is very much dependent on the uh, basics. Okay, uh, for example, if you don't understand how a data type and the variable are, if you don't understand how a data type and a variable are related, you might have difficulties in understand how a class and an instance is related. Okay, so understanding, asking questions, being inquisitive is very necessary when you are starting with Java. Apply. Whatever we learn, whatever we understand, we have to apply it practically. Java is very practical language. Java is a very real world language. Even the analogies that we use in training, or even the analogies that are there in the Java books that you read, are very much real life. We take examples of animals as classes, we take examples of vehicles as classes. So these are practical things, practical entities, tangible entities which you can see by your eyes, you can feel it. And if you are in that mood, it is very easy to make analogies and build the concept, unlike structural programming languages, right, which are difficult to grasp. Analyze. Once we apply, we have to analyze our thinking of logic, right? So logic is a very important building block. For example, if I am asking you to calculate a factorial and write a program or write an algorithm for it, there are various ways, right? But the correct logic will be using a loop. Okay, or there can be another logic. But if you analyze your learning, if you analyze your understanding, and if you analyze whatever you remember, okay, so if you analyze the first two steps, you will be able to drill down to the appropriate logic. So this analysis has nothing to do with this language. Same analysis you can apply to other languages like Python, Ruby. Okay, so if you in my experience, if you are learning Java, it is very easy to grasp or take over any other language as well. Evaluate. You need to keep testing yourself, right? So uh, I personally, being from a testing background, believe that testing and quality is very, very important. And we ourselves, if we consider ourselves as a product or a service, right, we are delivering a service. So our organization or our employer is using us as a service. So it is very
ಬಾಸೆ
important to
ಚಾಟ್ಸ್ ಬಜ್ಜಿ ಅಲ್ಲಿ ಹೇಳ್ತೀನಿ ಈ ಕಡೆ ಒಂದು ತಪ್ಪ ಬೆಳೆಸ್ಕೊಟ್ರು
ourselves whenever we are learning anything or whenever we are applying anything. Okay, so evaluation is testing yourself, evaluation is building confidence in yourself. Whenever we are provided with a problem statement, we are very everyone is skeptical. Even after we have 8-9 years of experience, if we are given a problem statement with a deadline, of course there is a deadline pressure in any organization. So we are really skeptical to start with whether we'll be able to accomplish the task as per the desired quality, because the expectation levels by the client are really high generally. So if you evaluate yourself, if you keep on testing yourself, you'll gain confidence, and with confidence you can do the wonders, right? You can even achieve what you cannot achieve otherwise, right? So evaluation would really help. So evaluation will really help us build confidence and work as per the requirements of the problem statement. Okay, so in programming, everything is a problem statement. When I say problem statement, I do not mean any practical life problems. By problem statement, I mean the task that we are given to solve by using the programming. Okay, no matter it is a test automation task, at the end of the day it's a problem statement that needs to be solved programmatically. Create. By create, you can see in the image that uh, okay, so yeah, so create, if you understand or if you follow all these 5 steps, If you remember, I'm not saying remember everything, because that is not feasible. By remember, we need to be judicious. If you understand, if you apply, analyze and evaluate, you can create. So you can see the placeholder under the create, the person is sleeping, right? Or it's, he's sort of resting. If all the building blocks are in place, your creation job is going to be hell lot of easy. Generally, what we do or how we proceed is, we start with the last step. We start with creating, right? So it is very important to invest. It is very important. It is very important in other activities before we actually start creating stuff in Java. Next up is resources and practice. So, to learn anything, you need resources. When we went to school, we need books, right? We need some resources. We need uh, teachers in school. We need tutors, right? Maybe home tuitions as well. So, it's not bad. Okay. So it's okay to have, resources, and it's okay to follow or refer the resources when we are working, right? It is generally recommended to new developers that uh, that you should start from scratch, and you should write the programs on your own, building your logic. But in today's modern world, a lot of programming is already being done. A lot of logics are already being resolved. I read a quote somewhere that most of the developers are surviving due to Stack Overflow. So I won't call it as an understatement, because that is practically true. I have also seen this in my career. But knowledge is really important. If you get the code snippet, at the end of the day, you have to integrate it to your project. And real world projects are very, very complex in nature. Okay. If you are building it from scratch, definitely you have to decompose it and logically divide it. But no matter how easily or briskly you divide it, you have certain pitfalls and limitations, like deadline and complexity of project, and you cannot work on it alone, and you cannot control all the individuals which are in your team, right? Even if you are a lead, even if you are a manager, everyone has a work pattern, right? So when work pattern of all the individuals is integrated on a single project, the real world test automation project, or even Java development project, becomes very complex to understand, right? If we blindly switch the team, even the best of the teams won't be able to take up the project very swiftly. They can take it, but it will be a lot of ramp up, and a lot of training would be involved. Okay. So it is important to be trained in a particular field before going full flashed working on it. Second is participation in code playgrounds. So there are a lot of code playgrounds going on, and which gives you practical exposure. Writing a tutorial or a blog post, or even the Java documentation on the Oracle official website, or Java official tutorial on Oracle website might not help. Up to the limits, the practical coding will help you. Okay. Because practical coding is the thing that we have to do on real time. Okay. So training and participation in code playgrounds give you the exposure of real time programming. Okay. Your fingers are on the keyboard, and your brain is searching for logic. It's exploring and discovering the logic. So that is the real test, and that is the real thing that we have to undertake whenever we are doing the coding. Okay. So resources we have to choose intelligently. uh, because we do not have an entire lifetime to learn Java, right? uh, I mean, considering the challenges right now which are there in the market, and trends are changing really really quickly. I saw in one of Java developers, I mean, the person who develops Java for Oracle, in his LinkedIn profile I saw that he is working on Java 9 since last 3 years. Okay, so see, they are really ahead. So they are really ahead than than where we are. And things are really changing quickly. If you compare Java 1.5 with 1.6, you'll find very limited changes. But if you compare Java 7 with Java 8, you'll see there are a lot of things introduced, and time to solve complex programming problems is drastically reduced, right? With so much technology and so much code uh, already present, the time to reduce complex problems is really reduced. So we need to be very judicious, and we need to be very brisk in selecting the resources that we are using for our Java programming. Okay, practice. So practice is really important, right? It's very well said that practice makes man perfect, and I mean, practice makes anyone perfect, uh, actually. So we need to invest our time, and we need to spend our quality time in practicing various things. Moving ahead, learning methodology. So we already saw what steps or what we have to learn. Right now, let us focus how to learn and how to start learning Java. Okay, so in the first slide of this deck, we talked about starting with basics, right? So in Java, we have to, or in any programming language, we should start with basics. I won't invest a lot of time in this since we have already discussed. uh, Next is invest time in right things, right? Since programming world is changing very drastically every day, we have a lot of new things, and the capacity of data generation is really increased. The velocity of data being generated has really increased in last few years, or in last few decades. So uh, programming data is also getting generated really rapidly, right? You can see if you go 10 years back, you might find say 100 Java blocks. Today you'll find million Java blocks, right? So there are a lot of things, there are a lot of learning resources, but you have to invest your time in right things, and uh, you have to be uh, working you have to learn like experienced professionals do, which which is very the output is really productive. Okay, if we invest our time in right things. Okay, because if we if we wander in the programming world, if you wander in the internet, you can lose your entire day without learning anything, right? This might happen. So we have to invest time in right things, challenge oneself. So you are the only one who you want to challenge. You want to give yourself some programming practice. It's a hard work, it's a boring work, but this is an important thing, or an important takeaway that I have from my experience, that if you need to learn, you have to challenge yourself. Okay, uh, then the core thing. Then the core thing. there are 3 Ds: the dedication, devotion, and determination. Okay, so we have to be dedicated whenever we are learning anything. I mean, this is this is not related to anything with the programming, but as a general, I have found out that being determined to achieve something would help you. Okay, and taking right approach towards that would help you. Structured learning. Structure means planning. Okay, so you have to plan it, you have to plan it out, you have to write it down. Okay, you write it down on a whiteboard, piece of paper, on a sticky note, wherever. Okay, place the sticky note on your laptop. Okay, do whatever, plan it out, plan it out. If you don't plan it out, I mean, it doesn't matter if you if you practice programming for 1 hour a day, attend training on weekends, do whatever, right? But plan it out, do it in a structured manner. Being smart, again related to invest time in right things. Okay, so I mean, you can follow the footsteps of other beginner Java developers if you are beginning Java, to be smart and do the learning. Follow the protocol. So we'll discuss protocol in the next slide. So yeah, so we are talking about this. So if we follow the protocol, we would be more than successful, right? Because protocol makes you disciplined, and discipline is very necessary. So this one protocol, if you can follow, or if you you can analyze this more, you can explore this more. I'm not asking you to blindly follow it, I'm asking you to understand it, and do your own research, and before following it. So protocol is nothing but set of rules. Okay, so the protocol generally followed at Techcanvass is the FLAP protocol, okay, which is functional learning approach to programming. Okay, so this protocol focuses on less theory and more practical. Okay, so we have a rule here: less theory. So theory is important, right? Theory is important. No one can override theory. Like manual testing cannot be undone anytime. You will always need manual testers. Similarly, theory cannot be neglected completely, right? Even in agile, we support minimal documentation, right? So even theory cannot be nullified ever. So less theory but more practical, more focus on practical, because that is when your logic way your logic nervous system, the nervous system, or the system which produces logic, is activated and working, right? It's burning when you are practical. Understanding structure. So we focus more on structure and logic, okay, than on cramming, or giving a hot list or cheat sheets. So more focus, in my opinion, also should be on the structure of how programming language is behaving. Okay, next thing is Googling. So as I told you that a lot of code has been already done, or is already been written, right? But you need knowledge. You can't Google and integrate it directly, right? You need programming knowledge to integrate the code, even if you find it on the internet. Next step is related copy, if you understand, right? So you cannot blindly copy, because for that instant, for short term, your problem might be resolved. Okay, but on the larger run, you can face a challenge with this copying stuff. Okay, and a larger run, your program might produce some serious errors and exceptions in the longer run. So you need to understand what the code is doing, or the code snippet is doing, or a program is doing, before copying it. Okay, divide logically. So whatever problem statement we have, okay, for example, a simple problem statement of addition. Okay, say I want to add two numbers. So we have to divide the problem statement logically into a structure, and then we have to start working on it. Okay, for example, first we'll say initiate the variables, write the logic of addition, and display the output. Okay, so this can be 3 steps in dividing the problem statement logically. Evaluation. Being inquisitive is really important. Okay, so we'll talk 2 techniques of evaluation here. okay, where we'll how we can evaluate ourselves. But evaluation means, being inquisitive in any of the ways. Okay, since we are, gaining knowledge since our childhood, right? So we have a system built in ourselves, which helps us being inquisitive, and we have our own way of understanding and learning, right? So you have to be inquisitive in your own way. Okay. One technique that I know is a programming hour technique. Okay, so you have to dedicate 1 hour, say every alternate day, every week. Okay, based on your schedule. So you have to dedicate a programming hour, and you have to challenge yourself, and you have to achieve the challenge in the programming hour. Okay, of course the challenge has to be practical, right? You cannot develop a 5-tier application in an hour. So practically challenge yourself and dedicate a programming hour, and work towards the solution of the programming problem. Next technique is into shell technique. So generally, I mean, used by Facebook developers, they, go into the shell. So if you see, Mark Zuckerberg's history, he went into the shell, right? He put his headphones on a high music. So there is a lot of focus music on YouTube. If you find it, if you search it, you'll find it. So he what he used to do was, he put a lot of focus music on a high volume, and he went into the shell, right? He went into the core. Okay, so into shell technique is, really focusing hard uh, with no distortions or no distractions at all, and working towards the problem solving. Because in programming is like, they are large threads in your mind, right? So you have to weave the logic in your brain. So this is what I had, and this is what my views were towards stepping into the Java. So concluding, the takeaways are that we have to follow, there are few steps we have to follow, certain methodology. Okay, we have to be disciplined, follow a protocol, train ourselves, seek professional help if required, and invest time. Okay, so these are the key takeaways when you are stepping new into the Java. So I'll pass the yeah. So I'll pass the control to Ravi Rai now.